This is Breaking Down Security, and I'm Brian Brake. Welcome back, listeners. This is Breaking Down Security. Mr. Betcher, how are you doing this week?
How you doing? I'm doing all right.
Yeah. Well, my Chargers aren't in the playoffs, so I don't care a lot about what's going on with football. But I hope everyone else is having a better job than enjoying their team. So, yeah, I'm kind of sad because football's over for me this year. So, you're what team are you following? What are you, the Texans?
No, I don't do NFL. I just do college.
Oh yeah, I can't do college. I have to wait until they're spoiled millionaires before I care. So, yeah. So, all right. Well, enough of this jibber jabber and small talk. What are we doing this week? What are we talking about? What's our topic to engage the senses?
Well, I've been thinking about getting some more of the 24 Deadly Sins. I really like that book. I learned a lot from it. Even though it's kind of dated now. It's about 7 years old. I think it's the second version. Mm-hmm. And so we took that with a grain of salt, maybe updated some things as well in the show notes. So the topic today is called Cryptonite. Top 10 encryption pitfalls that could turn your app into crap.
Yeah, and we made it crypto, like CRYPT, Cryptonite. Ah.
Yeah.
Yeah.
I just got that. Just kidding.
Well, yeah. So, so we're going to talk a little bit about the various gotchas that developers do or have done that these folks, people like Michael Howard, who helped write this book, to tell you how to not do things, do certain things that are bad. So, so you want to start with number one, because that was one that you really liked a lot.
Well, I was just looking at it, and it looks like we have 11 things, so 10 is kind of an arbitrary number. But yeah, let's start with number one and just, it's kind of a random list right now. So,
sure.
The number one is using crypto that's unvetted by the global cryptographic community. So you've heard of this quite a bit. Don't roll your own crypto, right?
Exactly.
You could get into trouble that way. And just as an example, they list in the book, out of the 15 algorithms that were submitted to the first AES conference, that was a contest to come up with an AES, I forgot what A stands for, but the ES is encryption standard.
Advanced encryption standard?
Advanced. So for the time, it was the advanced encryption standard. So two of them were broken before the conference even started.
Yeah.
All right. Of the 15. And one of them was broken pretty much when the conference did start or during the conference. So these are some of the best cryptographers in the world submitting these algorithms. And it takes a lot of work to make these algorithms and run through the initial tests. And for three of them to just be broken before it even started is kind of eye-opening as to the level of difficulty it is to get a good algorithm going.
Well, I often wonder about that, because it's like some of these people must spend years trying to make these things happen, and then you take them to basically this dog show of crypto standards, and somebody just runs over your pet project that you've been working on for years with just something that's really simple, or maybe you knew it was crap when you started working on it, but you didn't, you thought you could fix it in the wash, that kind of thing.
I don't think it's easy to break these algorithms by any stretch. I mean, if you look at how hard it was to break Enigma, I mean, if somebody came up with the same type of Enigma today, or if somebody like a hardcore cryptanalysis cryptanalysis guy, I don't know what they're called, cryptanalyst, were to take Enigma right now, they could just eat through it.
Well, sure,
like it was nothing, because we have computers today,
yeah,
right?
yeah, exactly. But some of these is like I'm reading from the article you found, and it's like magenta. Where do I start? There are so many security problems with this algorithm that it was broken during the question session at the first AES candidate conference. So I'm wondering if some of these is like we do it because it's fun math. Never mind the fact that security is involved, and uh, I just find it odd that people would spend so many years and not realize that they could break it so easily. So
well, other people would have, maybe people that have been doing this for longer or looking at it from a different set of eyes. They have different techniques. Like if you open the link, which I'm doing right now, and there's one, such and such fell to a differential attack. Yeah. Right. What is a differential attack? I don't know for sure what a differential attack. It might be something that I'd, if I were interested in cryptanalysis, that obviously I'd know what that is. Yeah. But they seem to, it's something that's very commonplace. All right. And you got the plain text attack, the known plain text, and different attacks like that.
Yeah. Yeah. So out of all of those, they're still trying to figure out what the new, AES standard is. They recently just had one, I don't know, what was it, a couple of years ago, where they were trying to replace, because as MD5 and SHA-1 becomes deprecated, as we've heard in recent news that Mozilla and Google are going to be deprecating SHA-1 on certs, so everyone needs to go to like SHA-2. Right. They created SHA-3, or whatever the SHA-3 standard is, and they had several dozen entries on that as well to come out with competition. It's interesting how they compete with that, because I guess with that you're actually competing with more immortality, aren't you? Because the winner of that becomes pretty well known as the creator of the standard that millions and millions of people are going to use today.
Right.
So,
right.
Wouldn't it be important for a person to go through the proper steps to have that done? I mean, it'd be like, it's not like creating a new WordPress plugin or anything like that. But, if you're going to create secure code in one respect, whether it be a WordPress plugin, you should try to be as secure as possible when creating the underpinnings of technology in this case.
Right. And that's why they have a contest and pick the best one and have it go through the ringer. And again, the crypto community looks at all these with a fine-tooth comb, and they're still looking at them, right? Which is why they're deprecating SHA-1 as we get more advanced and people try different techniques and things on these algorithms that, they tend to, with the faster computing, tend to deprecate them more and more quickly now. As you see, MD5 went away, and then SHA-1 is starting to go away, and it's only been a few years later. So they had a competition for SHA-3, which went from 2007 to 2012. And there were 64 entries for that. I think 10 of them were just completely owned at that point. And if you look in the show notes and you click on the SHA-3, the flaws, many of them had flaws. You can see where a lot of them had collisions, in them. If you scroll down to the bottom, it gives a list of all the entries, and it shows some of them that didn't pass round one and kind of what was wrong with them.
Yeah, I remember following Bruce Schneier's blog about Skein. He was trying to create a new hash for SHA-3, and he was talking up how Skein was going to be so awesome and everything, but he ended up, being like first runner-up or something. I guess if Keswick couldn't perform its duties, that Skein could move in there, kind of like a pageant or whatever. So,
so it's important to.
Wow, that's a lot. Look at all those. Collision, pre-image, second pre-image. Wow. Yeah. Okay, that's a lot of good
So
information.
it's important that you use an algorithm that's been vetted in this manner. I mean, you're talking about the best of the best at that point.
Yeah, not
Right.
just crypto, but your hashing algorithms as well. Because if your hashes are easily guessable, or are prone to having rainbow table attack, or can be derived easily, then yeah, you're going to have issues. So don't roll your own crypto. Don't roll your own hash algorithm. Use what's out there. Use what's been vetted by people much smarter and more beardy than us.
Exactly. So moving on, number 2, encrypting something that's already known in your application. If you have something that everybody knows already and you just encrypt it, because that's bad, because it could be subject to things like rainbow tables, or the known plain text attack, which you can hear sometimes as crib. That's slang for cheating. Known plain text is considered to be cheating by the crypto world, and I think that term was coined by the guys at Bletchley Park.
Bletchley Park, yeah.
Yeah. So where you have the happy birthday Adolf Hitler message, that was encrypted thousands of times. So they had their known plain text, right? And then they had the weather of the day. Why would you encrypt the weather of the day? All right. It's no.
I can give you a good example of why we would need to encrypt the weather. When I was a weather observer in the Navy, I had to take observations and transmit them over this new thing, and this was back in around 2000, called the internet, to various organizations for ingestion into numerical weather models. And the problem was, for ship observations, they give you Latin long. So they have to be encrypted. They have to be secure, because when you post the observation, you have to post the point on the map where the ship is exactly at that second. So, for land-based areas, it's a little less secure, but for ship observation, for the Navy at least, you have to give Latin long. So obviously that presents operational security hazards. So that would be one reason why you would want to encrypt. So if a U-boat back in World War II, for instance, was sending out an observation, they wouldn't want to say, well, we're at latitude 53, longitude 117 or something. That would be bad. So that was just an example I thought of right off the top of my head. So yeah.
But for a stationary object like a base, or a fort or something like that, or a city, weather of the day, not really important to crypto. But I can see where you wouldn't want to give away your location.
Yeah.
Certainly.
Yeah. Yep. So,
but you wouldn't want to start your encryption with the weather here is.
Oh yeah. Right. Yeah. I was just thinking about reports. If you're using a weather report and it's encrypted, the fields involved, unless you're using some kind of where you're jumbling everything together. And observations are normally encoded anyway. So if you have all of it in one line with no spaces, and you're not encrypting things like, if it's 4 characters, then you've got an encrypted 4 characters, then that can be something different. So you'd want to jumble it up. You want to take out all the spaces. You want to obfuscate the text before you then encrypt it, and that might help with that. So using, all
right, number 3,
using encryption instead of hashing where encryption is not needed. So this is a Bob story, isn't it? Where I remember discussing this with some developers back in the day, where they wanted to encrypt certain data, or they wanted to encrypt hashes.
No, they wanted to encrypt passwords or pins, right?
Oh, that's right. Yeah, pins, and they're of a specific size. So you got a 4-digit pin, you want to encrypt a pin. So that's an easy rainbow table thing.
That is a rainbow table thing, or it's known plain text pretty much. So if you have a 4-digit PIN and you're going to encrypt that, why would you need to? You only have to verify the PIN, right?
Mm-hmm.
You don't have to go in reverse.
Yeah.
So hash the PIN with a salt.
With a good deal of salt.
Right.
Yes.
So you don't have any of the hashes in your database table that are the same.
Well, the problem with that is pins are really hard to hash anyway, because if you know it's a 4-digit pin and the salt is already in the database, you can pretty much, derive things pretty easily. So, not having pins at all in your database is probably a good idea to begin with, or have some method of, they call it peppering, I think, as well, which is a value that is outside of the database that is used to further obfuscate the value of those things. Yeah. So, I mean, that's, pins and passwords are just hard. If your passwords are too simple, then you're going to have issues. Your pins, especially, unless you're using like a 8 to 10 digit pins, which nobody uses, that can be a thing all by itself. So,
but we'll talk about key derivation functions later, and that'll help as well.
Yeah, that's right. That's for another later in the show. So, I have the 24 Deadly Sins book too, and I looked at it and I was like, oh, this was written like 2010. Okay, well, it's been 5 years. Let's see if there's been any changes that people need to think about. So I started looking up, normal crypto issues that come up that you can find. And, in the book, they mention where old versions of Microsoft Office store the password that you use to protect or encrypt the file inside the file itself. So if you open it with something like a binary editor, like, I don't even know what a binary editor is. I use strings, but that only shows me the strings inside the file. So do you have a binary editor you use?
Yes, but I don't know the name. It's a hex editor.
Okay, so some kind of hex editor that puts a binary output, and you can actually reveal the password and save the file after you've removed the password, and you're good to go. And
awesome.
No, not awesome. Because the idea is somebody thought that it was a good idea. Some developer somewhere thought it was a good idea to have that in the file associations. Like, who would reverse engineer or open up a Word file in a binary editor? That doesn't make any sense. Why would they do that? And in fact, somebody did. They also mentioned WUFTPD, which if you could get it to core dump, then it stores the passwords in actual memory, which is kind of funny. You can sort through the core dumps and get passwords that way. You've also heard stories about people putting their software keys, their API keys, or their passwords in their GitHub repos. They just leave it in the code. So, I don't know why they do that. Maybe they think that nobody will actually use them, but you can get access to APIs with the API keys that way. When you're developing code and you're developing applications, you want to keep an eye out for these kinds of gotchas, especially if you're using code repos. Maybe you're not supposed to be sharing your API key with people, or, if you're using Amazon's, like for instance, you don't want to have a lot of connections being made to your Amazon, because I know that we've actually locked out accounts, or Bob has actually locked out accounts at his workplace because of an application that was querying the AWS dashboard too much.
Google.
Yeah, Google, anything with an API, if you ping it too many times, you can cause denial of service, or if they have controls in place to limit the amount of connections, you can lock yourself out. The other thing is, you shouldn't be storing your passwords inside your applications anyway. You should only be putting the verifiers in. So, don't put your password 123 in there. You put like the hash of it, or a salted hash of it, to reduce its use. As we mentioned later on with key derivation, and as long as you're as long as you're not able to easily reverse engineer or reverse or derive the hash anyway, it's going to take a long time for the attacker to get into that, and they would get discouraged.
So they have people who search Google looking for passwords in code.
Oh yeah, Google dorking all the time. Yeah.
So
yeah. So I guess what's worse than rolling your own crypto, Mr. Betcher?
Not having any, I guess.
Or number 5, using outdated encryption.
Oh, okay. Yes. Number 5, using outdated encryption. If you use DES, which is a 56-bit key.
56-bit, yeah.
Yeah, but of the 56, not all of them are actually used for the core algorithm. So it's even less than that.
That's true. Or if you use triple DES, but you don't use 3-key triple DES, because triple DES, there's like 1, 2, and 3 key triple DES. So every time you make a connection, a different key is used. But if you use 1 key in triple DES, it's actually not as secure as most people think.
So yeah, if you use older crypto, if you use MD5 hash algorithm, that's deprecated. If you use XOR to encrypt,
RC2, ARC2, yeah, that would be an old one you wouldn't want to use.
Yeah, so there are lists. FIPS 104-3 has that list of algorithms that you want to use, or if you want to look at, whichever one works for you, or that you can implement.
That's 140-3, I think.
Oh, did I say 104?
Yeah, no,
I'm
that's okay.
dyslexic anyway, so.
Yeah, that's all right. Yeah, FIPS 140. That's like I don't know. A lot of government institutions use 140-2 and the new 140-3 to make sure that they're following the proper cryptographic modules and algorithms that are still strong. So yeah.
Okay, number 6, using weak random numbers. So random number generator would be able to give you let's say it gives you 10,000 random digits, and the key is that you would never be able to guess without with more than the standard probability to guess the 10,001st digit.
Yep.
For example.
Yep. And back in October, there's a link to a threat post article about prime Diffie-Hellman weaknesses may be key to breaking crypto. They were talking about there was something called logjam, I think, that if you used too low a server number, the logjam attack against TLS protocol. So if you use a less
the prime seed is what you're talking about?
Yeah,
if you use a prime seed that's too small.
Yeah, so they were using 512-bit primes in TLS in some cases when they were doing Diffie-Hellman key exchanges between the servers for making the secure connections. And logjam was used to, you could derive keys. I think that's what it was. Let me see. You could. I'm reading the weakdh.org site.
I've been there.
Yeah. So passive eavesdropping from an attacker. They were talking about using nation state resources if you're using 1024-bit. But yeah, most organizations were using 512 still because they hadn't upgraded in a while. So there's a lot of organizations out there, and they suggest you use a 2048-bit because that still hasn't been broken yet. I actually saw a talk about this at HushCon this year. That was quite interesting to hear them talk about elliptic curve Diffie-Hellman and how it's different. And
it's important to use these strong random number generators because of your initialization vectors, like you were talking before the show, SSH, right? Yeah. If you use a crappy initialization vector, say on a or the same one on a golden image, then your SSH is going to be pretty much the same as far as a predictable random number seed for your SSH
and your
sessions.
initialization vector is an arbitrary number that is used along with your secret key for encryption. So it's also called a nonce, which a nonce means like it's used once and then it's used only one time in any session. But yeah, I got on the mailing list for OpenBSD, and they were talking about the fact that when you're building a basic box with nothing on it and you first start it up, the first thing that happens is it generates the server key. But if you build your boxes the same way every time, your boxes will have the same key, basically. I mean, it uses the entropy created on the first boot, so there's not a lot of difference in the system. So, after you get the basic idea of the box down, so if you're using it as a mail server, after you get the mail server and everything set up and you're running through some processes, it would then be good to run and regenerate the server key. Because it'll be different than the web server you just built, or the database server you built, or the whatever. Having that additional entropy or the additional randomness is important when you're building a server key.
If you were a nonce, I'd use you all the time.
You'd use me all the time if I was, oh, that's sweet. Is that a Hallmark card? Did you read that on a Hallmark card?
Actually, my girlfriend on Twitter tweeted that out. InfoSec Taylor Swift.
Okay,
I can't take credit for that.
Is that your wife over there with the ball bat? Yeah. Saw that, boy. So, number 7. So number 7 is hard coding encryption. I think we see that a lot. Actually, we see a lot of the hard coded passwords more, which is the next option. Hard coding encryption is not a good thing to do because.
What do you mean by that? Hard coding encryption?
Well, like using the same crypto ciphers and not having the ability to upgrade them later on, or if you're using,
so you dig yourself a hole.
Well, yeah, and especially in SCADA systems, or systems that don't get a lot of love and attention and upgrades. If you're using, 10 years ago, SHA-1 was great, but if you're still using SHA-1 on that box, or if you're still using, I don't know, if DES is still something you have to use on that box, that's not something you want to be using now. And you need to have the ability to upgrade that. So when you're building your applications, you're building your code, you're building your firmware, you need to make sure that the ability to upgrade is possible. You got to think about methods.
You got to build your system dynamic, right? And not hold fast to one encryption algorithm. I mean, the man himself, Michael Howard, gave me some C code. I mean, he practices what he preaches on. It's just a small bit of code, text executable that will encrypt whatever plain text you have, in in a number of encryption algorithms, triple DES, AES, I forgot some of the others.
Yeah.
But yeah. Well,
and anything elliptic curve is still relatively okay. There are a few that they don't suggest using, but that's I want to talk about elliptic curve more, but that's going to be another show, I think.
So if you're a developer or you're in charge of a project, maybe you're an architect, be thinking about making sure that you future-proof your application when it comes to encryption.
Yep. Yeah, and I was talking earlier. So hard-coded passwords is another one. Every time, it never fails. It always seems like at least once a year you find out that your home router has, either a hard-coded password or it has a static SSH key that is on about 10 million different, routers that if anybody got a hold of, they could derive the private key and get onto your box. Again, making sure that if you're using hard-coded passwords for testing on your application, especially in things like firmware, make sure your QA folks go through that and look and make sure that they remove those values. Or, if that's just code you're using for testing, to remove it before it gets into production, because you don't want possible code used for testing, with passwords in it to be released in the environment. Especially if you're a SCADA system. I think I heard one where they had a SCADA system that had a hard-coded password in it as well, which is a nightmare.
One way you can find. Go ahead.
No, because it's going to be a nightmare because it's going to be 10 to 20 years before those systems get ripped out of, a nuclear reactor or, a dam control system. So
one way to find hard-coded passwords in an app is to run strings.
That's
on true. On the binary and see what comes out. If you get like password in there with dollar signs, test out wherever you can put in a password.
Yeah.
Test that value.
Yep. So one other one that came up in the book was, when you're, not everything is development, but if you're using, encrypted channels or something like that, and you're testing an application for somebody, one of the things you want to do when you're testing for these is making sure that you can't do a replay attack against your application, which would be taking the data or the traffic after it's been man in the middle, running it again against the host to see if you can get a successful login. And one of the things that they mentioned in the book and online is one, you need network access, which is a network control all by itself. But this is for web application people. You want to use proper session tokens. You want to regenerate your session tokens, after login, especially. Bob knows of a certain web application that when you logged in or when you first visited the website, they gave you a session token. And after you logged in, you didn't get a new session token. And, if you came there on an HTTP request and then you got moved over to the HTTPS request and it didn't regenerate your session token, anybody could man in the middle you and see your session ID and use that in either a CSRF attack or, just impersonating you on the website later on if the session token had a long enough duration. So
let me see if I can if I get what you're trying to say. So the attacker would man in the middle you, watch you log in, and then he would be using an interception proxy on his machine, and then replay all of your requests and see that he got the same responses from the server, and then he would have a valid login session at that point.
That is true. Yeah. I mean, that's pretty much the way it works. Yeah. All right. So it's good to regenerate those. Sometimes if you want to be real paranoid, every time you make a request back to the server, it regenerates your session token for you. Or, once you close your browser, they always say close your browser and clear out any cookies. That would clear out your session tokens from your box. Or you could just have the server do it. You could either have the client do it, which we know clients don't do those things. They just close the browser and they go on. Or you could have the session, once it's been terminated, the server will invalidate any of the session tokens that are already in use, which is always a good thing. The other thing you might try is timestamping. I read this. This is something new to me that I hadn't heard before. According to Wikipedia, and there's some other links on that page, timestamping is a way to prevent replay attacks. Synchronization can be achieved using a secure protocol. And then they use a Bob and Alice, where Bob periodically broadcasts the time on his clock together with a MAC, which is a message authentication code, I think.
Yep.
Yeah. And then when Alice wants to send Bob a message, she does a best estimate on what the time is on his system, which is also authenticated. And then he only accepts the messages for which the timestamp is within a reasonable tolerance, which is kind of interesting. So obviously you're going to have about the same amount of time. So if somebody's trying to man in the middle you, presumably the clock amount that Bob is going to have and Eve, the bad guy person, is going to have are completely different. So that would reduce the amount of replay attacks or session hijacking attacks. which is interesting. I've never heard of that one before, so that one was new for me.
Well, you got to make sure your NTP is up to date too.
Well, yeah, if you're using your NTP's off by 10 seconds, then yeah, well, actually timestamping would be good for that because it wouldn't really care what the time is on your system, or if the time on your system is correct. It would just hope that you had the right time period, right? So if you were,
well, if the attacker can change the time on the server,
right,
then
yeah, that makes sense.
Yep, or his own system.
Yeah. Okay. So what's this remote login over unencrypted channel? Is that just like not, making sure that your application doesn't allow like connection over a VNC connection or something?
Yeah, so make sure that all logins. I mean, this is pretty elementary here, but it happens a lot. I mean, I've seen it probably 6 months ago on an app that was just implemented in an org where it had unencrypted logons, and I was like, whoa, what's going on here? And of course, your vulnerability scanner should pick that up right away. If it doesn't, then it's pretty basic, but make sure that any login is going over HTTPS.
Yeah, and specifically as TLS 1.2, because that's the new hotness. I know they're in draft for TLS, I believe 2, but yeah, if you're using SSL, well, you don't want to use SSL.
There may be other types of logins that aren't over HTTP as well. Maybe a proprietary type of connection that's not encrypted.
Yeah. Or, if you have to run a remote login that doesn't use encryption, you can always use an SSH tunnel, or you can set up an SSL tunnel using OpenSSL to make that more secure for you. That's something you definitely want to look for if you're a tester or a QA person or a blue teamer who's running an application. You want to see, look for the unencrypted data running over network. So.
And there's some security tools that until recently that I am aware of that used unencrypted protocols, to control boxes even.
Well, yeah, VNC is one of the more well-known. People did use RSH and RLogin. What do you have another example?
Well, I'm not going to name names, but
it's not like
basically it was well, it's similar to that.
Okay.
It would basically, like a host-based monitor.
Okay. All right. I remember a couple of years ago, Symantec had their PC Anywhere where the source code was stolen. So, even if that was an encrypted, application that used encrypted channels and stuff, the fact that the code was leaked would probably mean that any, vulnerabilities found in that would make you not want to use that at all. So, it's a
good policy to have in an environment would be. If you see any unencrypted traffic, that should be inspected or looked into, right? Sure. Anything that's unencrypted in a secure zone, you basically need to check it out, see where it's coming from, and see why it's, or, if it's got benign data, maybe that's okay. But they're saying even things like NTP that we mentioned earlier should be encrypted.
Yeah.
And I think there's a new version of NTP that's coming out pretty soon if it's not out already.
Okay.
Yeah, it's not widespread adopted yet, but it is. I believe it's encrypted.
Would you, being the log guru masterman that you are, would you suggest that log files being sent to a log server be sent over an encrypted channel?
Yes, definitely. Because what if I typed my and I'm sure this happens to anybody. I type my password accidentally into the username field. Okay, and if that's sent over the wire unencrypted, there goes my password.
Yeah.
And I may be just a regular employee, and I don't know that, right?
Yeah.
Oops, I typed my password in the username field. Let me change that. And all of a sudden, both my username and my password go out off the wire unencrypted.
Yeah.
Right?
Okay. Well, that makes sense, I guess. So when you're creating applications, any of the output that you have that goes to whatever various log files should be encrypted, and that's just across the network. But I guess for a developer, log files aren't a big deal, right?
Syslog should be encrypted through an encrypted channel. One tool I used was Hawk in a former environment, and that by default was not encrypted.
Okay.
So, but it had the ability to encrypt, but that wasn't the standard. So you had to know that and then go in and change it. It was easy to change, but you had to know that it wasn't encrypted in the first place.
Yeah, it'd be sad that they didn't change the defaults so that you had to unencrypt, uncheck the box to unencrypt. So, all right. So now we're getting to that part of the web, the web podcast here where you were talking about key derivation. Maybe you could explain what key derivation is to us layman.
Okay, so a key derivation function would be something that puts your you could use it to, as an example, take a user's password and hash it to put that value in a database. And what's different about just regular hashing is the key derivation function would take a hash algorithm, it would take the password, it would take a salt, and it would have a number of iterations that were defined by you. So you could take, let's say I wanted to do, 1,000 iterations of SHA-1.
Mm-hmm.
So I put that in my application in the key derivation function, and I would choose a random salt for that and shove it through the function, and then I would get that hash and store that in the database along with the salt value that I received.
So in the iterations, you're actually hashing a hash, but you're hashing a hash every like 1,000 times.
Yes.
Okay, I was told that hashing a hash is not a good thing to do, but apparently we're doing it 1,000 times. So doing it twice is not good, but doing it 1,000 times is okay.
Right. And, LastPass by default does it 5,000 times.
Okay.
Now you can change that value as well and say, well, I don't want to have the default of 5,000 because then if somebody took the hashes or were able to steal the hashes, like what happened recently, they would pretty much know that it's 5,000 iterations and they would get it. Well, what if I change mine to say 5,120?
Yeah.
Then they wouldn't know where that ended. Typically, if they just took the database, they would have to take more than just the database at that point.
Okay, so the idea would be that you would want to make it as processor intensive as possible to get back to the original key, salt, and password, basically. So you would want to make it as processor intensive as possible. So 1,000 MD5s is nothing, but there's different processors out there. Like one of the more well known is PBK DF2. There's bcrypt and scrypt are the big three, and then you mentioned Argon. There's one called Argon as well. But so that you've got to make it, you've got to build enough attacker debt that it's going to take them a long time to get back to the original values. Sure.
Well, let's say for my application, the way it's deployed, 5,000 iterations is what we can handle. Okay, let's say we put them on our own servers, or let's say they're made for this type of, if we sell it, this type of server, as far as horsepower.
Yeah.
3 years from now, computers will improve. Maybe 5,000 is not good enough.
Yeah.
Or systems are up to date enough to where they can handle 10,000 iterations. Moore's law.
Yeah.
Okay. So it's easily changed on the fly. Again, going back to being able to dynamically upgrade the standard in your application, change it to 10,000.
Yeah.
So that it takes that much longer.
The problem is when you do that kind of thing, you're going to have to, especially if you're using passwords or something, you're going to have to make sure you update your passwords on your system, because if you start using, if the value of your password is this and it's 5,000 iterations and you go to 10,000 iterations, they're not going to match up. So you can't actually get the password back, that kind of thing. So you want to make sure that
your your application has to be robust like that. It should take a variable number of iterations. It should be able to take a variable cryptographic standard, right? Because if AES is broken tomorrow, you got to choose something else.
Yeah.
I mean, there's or if SHA-1, you're using SHA-1, you got to move to SHA-256 or SHA-3 tomorrow. Could you do that? No, of course not.
Okay, so let me ask a question about the robustness thing. Why would people want to? Because you're an evil developer now because you have an application that you use. Why would somebody lock in the crypto, the type of crypto, or the bit length, or why would they make these values static instead of making them have the ability to be upgraded or more random? Is it a development thing? Does it take not as much time to develop if they're locked into one version?
Oh, of course. Developers are lazy, and if you want to make your application robust, I mean, that's a lot of work.
Okay.
You got to test it more too.
The theories
you got to test it with all these different standards, where if you just choose one and you hard code the number of iterations, then that's much, much easier.
Okay. So, Brian Betcher does not speak for all breaking down security. So I don't think all developers are crap. So, yeah.
I didn't say crap.
Oh, I'm sorry. Yeah, the lazy. I'm sorry. They're lazy. All developers are lazy. So you can send all your hate mails, Mr. Betcher. I love developers. I think they're great. So, so the idea is basically time saver. It also saves time in the QA because they don't have to fuzz as much. They don't have to, test as many inputs. Basically, that's the idea. So when you're using encryption, it's just easier to say, okay, we're going to use AES 256. Everything tests on AES 256. Of course, shouldn't subsequent versions come out and go, okay, this time 512 is what we're going to use, or we're going to get rid of AES altogether and use elliptic curve.
Well, and then it becomes harder to change, right? So if you don't make it robust from the beginning, and then you say, oh crap, we better move from AES 128 to something stronger, then you got to redevelop it, basically.
Okay. So you're looking at development time making those changes.
Yeah, and then you got to do it again in 5 years, and then again in another 5 years. So if you expect your app to be there in 5 years, and still have a decent level of security built in, then it definitely should be dynamic. If you're just making an application that's here today, gone tomorrow, then okay, fine.
Well, that's interesting. Is that what most developers think, that their software is not going to be here in 5 years' time, or are they only thinking in a short-term type of fashion? You think? Because I mean,
that's what most people think.
Well, I mean, yeah.
I mean,
that's the only reason I can
companies
think
nowadays. What's the most important quarter?
The next one, or the current?
This one.
Okay, the current quarter.
Yeah.
Yeah. Okay.
Right.
Got to get your dollar bill, I guess. Yeah. Okay.
Yeah, because I might not be here next year. What do I care? As long as I get my paycheck, it's that
true.
kind of attitude that creates this level of, I'm only thinking about today. If we can just get through today, we'll worry about that tomorrow. Or my replacement can worry about that.
Oh yeah, that's other people's problems. In 5 years, I'll be, 3 other places, and I won't even care about this application.
Yeah.
So a lot of the stuff that we're seeing now, where you know the the passwords are hard coded in, that could have been created by somebody who doesn't even work at the company anymore. And
Oh yeah.
if you don't do proper code audit, you're never going to find those things. And it's important to make sure that your code does get looked at on a regular basis. Like the Juniper stuff that just came up, they found out they're using crap, crypto, inside of their VPN appliance. So if you, they found it in a code audit, which is kind of cool that they were doing code audits. But if they didn't do a code audit, that could have been sitting there for years or so. And actually, it was sitting there for about 3 years, from what I understand. But it could have been much longer. It could have been much worse. So. Yeah, so I think we've beat this over the head. We were trying to do more for like developers, what developers should and shouldn't do when handling crypto. Don't try to roll your own crypto. Don't try to run your own hash algorithms. Don't try to run your own auth mechanisms. Make sure you're using,
But it's not just for developers. It's for anyone involved in the development of an application. It could be a project manager, could be an architect, or someone in management. If you see signs of these things, if you see these red flags, okay, then it's a basis to start asking questions and to get those risks out there. We hard coded MD5 in our passwords. We didn't use a key derivation function at all. That's a risk.
Yeah.
We need to
didn't
get on
even
top of
bother
that.
hashing them. We just put the password in because it was so much easier to just put the password in the system. So, yeah. Okay. So let's, at the end of every major section in this book, they have like a bunch of do's and don'ts. And, they call it spot the sin. They're spotting the sins during code reviews, that kind of thing. One of the questions was Jesus, this was a long chapter. Good Lord. Okay, so they say, and this is funny because this is 2010, so this kind of tells you how old the book is already. Do use SSL3 or TLS1 for channel protection, which of course, you're not supposed to use SSL v3 anymore. They said do use a random salt when appropriate. Do use random initialization vectors when you're chaining block ciphers. Do not build your own secure protocol when a higher level protocol works just as well or probably better. There's a bunch of stuff on there that, it's a great book. It's just some of the stuff.
Couple things. This idea of, they'll never be able to guess.
Yeah.
Right. What we're doing under the covers. That just doesn't work.
No.
And if you think you're going to be able to hide the algorithm under the covers, you're wrong.
Yeah. Or
right? There's a thing called.
If you're going to hide in the code, you can't hide anything in the code. There are a lot of smart people, and I met some of them last month that they'll find your stuff. You can't, think you're going to get away with something, because if your stuff starts getting popular, they'll start looking into it.
Yeah, I mean, there's this thing called, decompiling, or looking what's happening at the kernel level.
Yep.
Right. So there's ways to figure out what's going on under the covers, and just don't go there.
Yeah. Yeah, and I think there's some humility that needs to be built into a lot of developers. Your code, you need to make sure that you have a second pair of eyes on your code, and that maybe those pair of eyes will ask you these tough questions so that you go, oh, yeah, I got a password in there, but what's the big deal on that? Maybe you need to embrace and engage your security people when hey, we're putting out this new module. It's going to be able to do X, Y, and Z, where your security people will be able to go through a threat model with you, or go through, an exercise with you, and go, okay, you've got hashing functions in here. You've got an API call. how are you protecting the API key? Well, it's just in there. We've hard coded it in because, just for time and effort. And they'll be like, maybe you shouldn't do that. Is this going to be, is this going to be publicly available? People, oh yeah, it's going to be available on this site. Well, now everybody's going to have your API key. Maybe there should be a way to obfuscate it so that it can't be, using a hashing function, using a sol to use use the proper stuff. Make sure that you reach out to your security people. Maybe those security people can help your QA people help try to find that stuff on the back end.
And also, how you said this book is kind of dated. It's more than 5 years old. That just lends to how we need to keep up with the trends going on as security people. We need to know what's in and what's out. We need to stay on top of things like crypto and make sure that we're not using outdated crypto and not even know about it.
Yep. Yeah. So even in 2010, Mr. Howard and the authors of this book were saying, consider phasing out DES, 2-key triple DES, and SHA-1 in existing code. I think that was because they knew that the time would come where these things would be deprecated or even outdated. I guess they didn't think about that with TLS1 or SSLv3, but that's neither here nor there. They do mention using AES for symmetric encryption and the SHA-2 suite for hashing, which, in 5 years, that may be laughable as well. Using AES or SHA-2 for hashing. So, so that was that was very interesting. The one last thing I would say about managing your passwords and your key derivation functions is if you've got a database with, say, PII or credit card numbers or authentication passwords and usernames, if you're encrypting that information, and you should be encrypting that information as best you can, don't store the encryption keys on the same database. So keep your auth system separate from the data that you're wanting to protect. I know that that's not probably possible for a lot of people, but if they can crack your auth mechanism, they can get into everything on the box or everything in your system. So you need to have your separation of duties, like most people suggest. It's not just for people, it's for servers as well. And make sure that your auth system and any important data that you're trying to protect are completely separate systems, maybe separate networks. You want to segment that off. So that was the last thing I got, Mr. Betcher. Is there anything you want to talk about? Anything you want to mention as like a takeaway that you got from this section?
No, I mean, what you said about separation, they do make appliances that keep crypto keys in there as well. That are really nice.
Yeah.
So you can think about that if you've got the Skrill.
Yeah.
To fork out.
Yep, they also make hardware systems that create random numbers. So if you have an issue creating enough random number generation, there's companies out there that create those things specifically for that. So,
and if you need a key derivation function, Argon 2 is on GitHub. So
is that an endorsement by Brian Betcher on Argon 2?
I don't know who wrote it, and I haven't tested it. But it's there. And of course, these key derivation functions use well-known crypto like SHA-1, SHA-2, or you type in your own, So use it however you want.
Cool. Yeah. All right. So, Mr. Betcher, how would people get a hold of you if they wanted to get a hold of you?
I'm on Twitter at BetcherPwned, BOETTCHER. PWNED.
Very cool. I am at Brian Brake on Twitter, BRYANBRAKE. The official Breaking Down Security Podcast Twitter is at BrakeSec, BRAKE Sec. And, we're we're just all over the place on the internets. Last couple of weeks, I've been adding us to a bunch of podcast directories. We got added to Stitcher, so if you're a fan of the Stitcher, you can add us to your Stitcher app and listen to us that way. We're also on the TuneIn app. We've been on that one for a couple of months now. So if you use TuneIn, it'll act just like radio, and it'll play all of the episodes all the way back to episode 1, back all the way in 2014. We're celebrating our second year this week. As a matter of fact, today, January 10th, I think, was the first podcast episode. So this is our second anniversary, Mr. Betcher. What is that?
Happy birthday.
Happy birthday. What is that? The glass anniversary? I forget what the second anniversary is. The first one's like paper, and the second one was like wood or something. I don't know. Bubblegum anniversary. So you can get us on Stitcher. You can get us on we're on Facebook. We got a Facebook page there, Breaking Down Sec, facebook.com/Breaking Down Sec. Where I post a lot on Peerlist. They actually wanted me to pimp them out a little bit. They're a community for just InfoSec people, which sometimes the content is good, sometimes it's thinly veiled vendor stuff. So you take that as a grain of salt. You can always check them out over there. That was it for this week. And one last thing. I spoke last week, which is, I spoke on the 6th or 7th at Rainier ISSA, the ISSA group over there. They let me come and try to school them on some vulnerability management stuff. And I just like to thank Stephen and all the folks over there at Rainier ISSA for having me. It was the first time I'd ever given an InfoSec talk. They were quite gracious, and maybe it'll turn into something where I actually submitted talk for a con or something. So if you live,
you don't talk InfoSec every week though, right?
Yeah, well, I mean, like I said, I have a face for podcasting. I don't have a face for public speaking. The public speaking doesn't scare me. It's just I don't think what I do for work, or what I was interested in giving them on vulnerability management, basically an in the trenches kind of thing. Over the 15 years I've done vulnerability management, to explain how it used to be and how it is for me right now. And it was quite interesting, but they liked it. So I guess it was good. We had about 12-15 people, so that was nice. But thanks again for having me. If you guys are in the Tacoma area, check out Rainier ISSA. So all right, Mr. Betcher, do you have any talks coming up? I know B-Sides Austin must be a couple of months away.
B-Sides Austin, no, haven't submitted for any talks recently.
Okay,
so there you go.
Right on. Okay, so that was it for Breaking Down Security this week. Everybody have a great week, and we will see you soon.
Bye-bye.